So it is a very exciting meeting, this meeting, and I think what's really struck me is that there's only one moment probably in all of our careers where a new technology comes through that is completely new and changes the treatment paradigm, and I think CAR T has to be that technology within my career generation certainly. And what's different about it is that when chemotherapy came along, for example, we didn't have the scientific tools to really understand how it worked or what mediated resistance or, in order to develop it in a rational way, whereas now we do. So we have CAR Ts and a whole load of really exciting scientific investigations surrounding it, not just its mechanisms of action, but mechanisms of resistance, etc. And I think that's been the highlight of the meeting for me, has been seeing the interesting science around it so that you can sort of chart out in your mind a way forward. So I'll give you an example. The two licensed products we have in both ALL and lymphoma are effective, but clearly for most patients actually they're not going to develop a durable benefit. And one of the reasons seems to be that they're just not very physiological. So this CAR is it's an artificial receptor. It's introduced through gene technology, but it has very strong binding affinity, particularly with the CD28 messenger. It seems to cause T-cell exhaustion quite quickly. So a lot of the very interesting presentations have been about how they can make these cells more physiological, alter the binding parameters of the receptor, fiddle with the intracellular motifs that cause the signaling. And there was a very interesting presentation about how actually directing the where the CAR integrates into the genome, so actually putting it in the T-cell receptor locus, seems to produce CARs which persist much longer. So I think that's been the real take-home message for me, is how the science seems to show great promise in producing more effective CAR Ts.